Welcome to Configuring ScreenOS Firewalls. This is the session on device management and recovery. In this lesson, we're going to cover the working with device counters and logs and where to find this kind of information on the ScreenOS device. We're going to be able to connect to external management devices and servers that provide information for operating in the ScreenOS. We're going to talk about managing your licensing keys if you buy the optional features and need to install and maintain the licenses. And we're going to talk about how file management works on the device, your configuration and your image files, and how you can get them onto and off of the device. And then we're going to review the disaster recovery procedures, ways that you can get in there and basically reset the device or respond to issues when the device won't boot. Okay, so this is broken up into two sections. The management section, where we take a look at all the ways to connect and pull information to and off of the device, and the recovery scenarios, where we look at what you do when you want to reset or recover from a non-bootable device. Okay, there are a number of tools available internal to the ScreenOS device in order to see what's going on. First, we're going to talk about counters. Counters are available in all of these areas: hardware counters on the device itself, flow for traffic coming through the device, policy for configured rule sets on the device, and screen. So in the hardware counters, that's pretty much as you would expect. This is counting things that actually crosses physical barriers in the device. So hardware counters are a really good reality check when you want to see if traffic is crossing, say, a physical interface. Is that counter incrementing? Is that traffic actually physically being seen on the counter? Flow is, of course, the next step up from counters, because or from hardware, because flow is where you can look at how the counters across the aspects of the device are incrementing, so you can actually see the traffic comes in one area, leaves another, and flows across the device. When you configure a policy, which is where ScreenOS does its rule making in the firewall, you can have a counter on the policy itself. So every time traffic matches what is in that policy, it will increment the counter. So this will tell you whether or not the policy that's been configured is indeed seeing the traffic. And if it isn't seeing the traffic, then you have to look at your match conditions and see why that traffic isn't hitting the policy that you expect it to hit. And finally, we have this area called the screens. Screens in ScreenOS are where we have rules to block malicious traffic for the most part. So these are at the zone level, and there's rule sets available to block known malicious types of traffic. So you can turn on counters here and see how many of each type of attack filter is being hit. This can be helpful if legitimate traffic is not coming through your device, and you see a counter being incremented on a screen. It could be that it's mistakenly being blocked as malicious traffic when it's actually legitimate traffic. So those are counters. All a counter is doing is saying, I see a packet, I see a packet, I see a packet, 1, 2, 3, 4. That's the only information you're getting from the counter, and it's at these 4 levels. The next area you have for internal management are the logs. We have 3 types of logs that are on the ScreenOS: the event log, the traffic log, and the self log. Logs contain more information than counters. It's not just an incremental count of traffic that's gone through. Instead, there'll be a message associated with it, and a description of what's going on. So the event log is logging things that happen at the system level. So if the administrator changes something, if something configures goes wrong or alarms at the system level, it'll show up in the event log. The traffic log is logging transit traffic that's coming through the device. So these can be turned on policies specifically, and you can see then the details of the traffic that comes through. It'll show you field by field what's happening on that traffic. The self log is where events that occur on the security device itself to the security device itself. We mentioned in the previous lesson self-traffic, so things that are destined and terminated at the device are self, and events for self will be logged in the self log. Then the third area that we have here for internal management are alarms. You have a device alarm or a traffic alarm. Device alarms are something going on with the hardware that is sufficient enough that it's going to light an indicator for that problem on the front of the device. All these events get logged then into the device alarm log. Traffic can be set up on a per policy basic to alarm based on parameters. So it can send you this alarm message if you exceed percentages or counts of traffic and trigger an alarm. Later in this particular lesson, we're going to go over how those parameters get configured and those thresholds set. So these are the three major areas that we have information available to us when we want to go in and see what's happening on the device or to troubleshoot a problem. So let's take a look at specifically the interface counters. This is a get counter statistics for the interface Ethernet 0/6. And you can see the counter has all kinds of details of the types of packets that have passed through, and they're neatly categorized. Obviously, if you're troubleshooting, probably the first thing you want to do is reset the counters to 0 so you can see exactly what's happening at the moment you're looking at it. And that's done with the clear counters all command. That'll zero this stuff out, and then you can start watching what gets incremented as you're trying to identify the traffic that's coming across the interface. With the flow, we have the same command. Clear counters all is going to clear all of the counters, so it'll clear the flow counters too. So with flow, you can see that the counters for Ethernet 0/6 are listed here, and here you're at more of a protocol level as to what's going through the device. If you're interested in only a particular counter, you can pipe these commands as we mentioned in the previous lesson, just by piping and using the INC for include, and then the keyword of the counter that you want to see all by itself, so that it strips out all the other extraneous information that you're not interested in seeing. And then here's the event log. By get event, we can see what the most recent event activity has been, and you can see in this particular one, of course, when you log in, that's an event log message. You can see the status change of interfaces going up and down. You can see system configuration has been changed, and those types of events are here. So you can see what's actually most recent set of events on the log. Okay, to look at these more specifically, you have some manipulation tools. Each of those logs have a lot of information in them, so one of the first things you might be able to want to do is filter them. You can see if we start by just looking at the event log, if we're going to get the event log, we can match the output using that pipe command, or we can use the caret to redirect the output somewhere. By redirecting the output, we can dump it to a file and then say import it into Word or Excel to be able to do searching there. And then you also have the ability before doing the piping to look at the fields that are captured by the log. So here in the event log, you can see these are the fields available in the event log that we can filter on. We can look for things that match certain dates or exclude or include certain types of text. So we can see all the messages of when a administrator logged in. We want to know who made a change, so we can ask them why this change was made. So we can filter based on that login event. You can also sort what returns to the screen using the sort by keyword. So sort by the date. You can sort by IP addresses in the log, or the time that the unit occurred at. And finally, if we want to do that saving command, we use that caret to redirect, and then we can direct it to our TFTP server, and we can set the source interface of that TFTP server using the set TFTP source interface command. By default, the source interface is going to be the lowest numbered interface on your device, so your TFTP server may not be easily reachable from that particular interface. You can redirect it to whatever interface you want. Then once you've written that file out there, you can go pick it up and review it. So you can filter and sort to the screen, or you can filter and sort and then redirect to a text file that you can open and manipulate on your own computer. In the event log, there are the standard severity levels that are included, from information all the way up to emergency. These are increasing levels of potential problems on the network, obviously. So you can use these as a quick filtering mechanism for sure when you're investigating issues on the device. This is a typical output from get event that we had seen in some previous slides, and you'll notice that this column right here is the severity level of the event that's being listed. Okay, so logs are able to be configured by a wide variety of parameters. So on the CLI, you're going to use that set command again to configure a log, so set log. Then you're going to identify which log you want to set. In this case, it's the module system level. We give it a name and a destination name in order to set the parameter. On the web, all of these log configurations are under report settings, so configuration report settings, and the entire array of severity levels and locations of where these can go are available here. So you can see these are the keywords that will substitute in the CLI above for level and destination. So your level is going to be everything from debugging up to emergency, and your destination is going to be that column. Is it going to the console, to the internal log, sending it out email, etc. So these are all the destinations you can send something to, and the severity level. These are simply on or off. So we're setting it, we're putting that check in place. We're unsetting it, we're removing that check. This what you're looking at here is the default of what comes up in the default load of ScreenOS. Okay, so if we want to set alarm thresholds, we mentioned in the earlier slide that we can trigger events to occur that we're labeling to be an alarm. You can set the value of the alarm to be in a percentage of whatever's happening, or you can, in sessions, you can set it to be when a counter is exceeded or a percentage. And you do this on the command line by using the set alarm threshold command. And you can, as we mentioned earlier, alarm on memory usage or session. So you select the keyword that you want to create the alarm for, and then the value of what the alarm trigger level is going to be. There are a number of external management servers that either provide information to ScreenOS or can receive information from it. These include, of course, the domain name servers. Our device may need to resolve DNS names into IP addresses. The policies and other items that work on ScreenOS can operate by DNS name. So you can create a policy that says, if you're going to mycompany.com, it's allowed for these protocols, or if the connection is coming from mycompany.com, forward it to this particular server, etc. You can use DNS names, but of course you have to have a DNS server then configured. Network time protocol. It's always recommended that some standard network time server be chosen for all the devices on the network, and ScreenOS can be configured then to use that NTP server to keep its clock in sync with everything else that's running on your network, so that logging and things on this device are in sync with logs you might pull from other devices. ScreenOS supports Syslog, as you probably noticed on the previous page. So by default, all these logging messages that we mentioned are happening to the flash on the ScreenOS device itself. There is, of course, limited space there. Fortunately, you don't have to manage that limited space. You can turn on as much logging as you want, and the device will simply clear off old logs as it needs the space for new logs. Conversely, that means the more logging you turn on, the shorter period of look-back time that you have. So you do have to balance that on your local logs. Turn on logging only on what you really expect to need, and then you can always enable logging when a particular problem occurs on new sections later. Syslog, of course, alleviates all of that problem because it gives you an external logging server, external Syslog server that you can just ship these messages to, and you can decide on that server level, how many days, weeks, months you want to maintain in your Syslog database. ScreenOS also supports SNMP protocol, so that you can use a external management server to collect SNMP messages from the device, or send SNMP traps to the SNMP management server that you have on your network. The Juniper product, NSM, Network and Security Manager, we've mentioned a few times in the other lessons. This is a combination management server. It does have logging capabilities, and it does also allow you to do remote configuration changes and save configuration objects, apply them across multiple devices. So it's a combination management monitoring type server, available on both an appliance and in a installable software version for Red Hat Enterprise Linux. ScreenOS also supports WebTrends, external filtering server. So if you have a WebTrends device, the ScreenOS is able to intercept and forward the traffic to use the WebTrends system. Okay, let's take a look at how we actually configure these services. For DNS, the parameters that are required are the IP address and the interface. You can have up to 3 DNS servers configured on the device for redundancy. You can schedule an automatic refresh of your cached DNS addresses at a particular time of day, and you can also force refresh intervals at however many hourly intervals that you want to, or once a day intervals. This is configured on the command line by using the keyword DNS host. So set DNS host DNS 1.1.1.1 source interface Ethernet 00. So DNS 1 there indicates the first of the 3 DNS servers that you can configure. So you can configure host DNS 1, host DNS 2, host DNS 3, and they can be on whatever you need to identify whatever interface will be the outbound traffic where the request is sent for the DNS requests. To have a update schedule installed, you use DNS host schedule. This is a 24-hour clock then for what time of day you're going to do that automatic refresh of the cached records, and the interval. In this case, the interval is set for once a day, 24 hours, but these you can also use for 8 or 12 hours apart to force DNS refreshes. On the web, this is under the network section, network DNS and host, and then you will have a form to fill out here. You have your primary, secondary, tertiary 1, 2, 3 DNS servers, what interface they go to, and on the bottom of the screen there you can see where you configure the refresh interval. The top part of the screen is the host name and domain name that is applied to the ScreenOS device itself, not anything with the DNS server, but the host name and domain name for your ScreenOS device. Network time protocol configuration is very similar to DNS. The parameters we need are the server IP address and the source interface where the device is reachable, and the interval to double check what time local time is versus the network time, server time. And then this parameter is also available for preventing major shifts in time by days, weeks, or months. Sometimes in time systems, bad things can happen if, say, the time is shifted by a year or a week or a month, or large periods of time. So you can prevent the update from exceeding a maximum adjustment range if you perceive a potential problem with the ScreenOS device making a large time shift. To configure the network time server, you set each of the server parameters individually. Set NTP server. You can use DNS names if you have DNS configured. So here we have tic.usno.navy.mil, a public time server that's available. That can be reached on source interface Ethernet 00. Then we have our backup number 1 time server as talk.usno.navy.mil. Those can also be IP addresses instead of DNS names. It's optional. And at the bottom there we set the interval. Every 10 minutes it's going to resync its clock and double check that it's running in time in this case. There are up to 3 time servers that can be set, so you can have backup number 2 in addition to backup number 1. In the web interface, the NTP is under configuration, so configuration date and time. Here you can see two other parameters. These are also, of course, settable on the CLI that are included in this page, and that's the time zone that the device is in and whether or not to adjust for daylight savings time. So those are optional time parameters to have your logs in a friendly format rather than Greenwich Mean Time as the source. And the bottom here you see the same parameters we were talking about earlier: network time server, IP address or name, interface by which it may be reached, and the refresh interval. This also does support password protected network time servers, so that the password can be configured in here as well, as it can on the command line. To use SNMP to your management server, this is a listing here of all the set commands for the different SNMP parameters. All of the standard parameters that you would expect for SNMP are settable. You can of course, you can restrict which host is allowed to receive those SNMP messages, so the host restrictions are available. It supports both normal SNMP gets and traps, so if you want to set a trap host, that's available, and it supports version 1, 2C, or version 3. So you just go through the list of your SNMP parameters and configure them as you have as your standard for your management server. On the web interface, this is also in the configuration area, so configuration report settings, and then SNMP submenu, and here you see the configuration screens that you would pull up to enter these addresses. The first one gives you your general settings, like your text fields and the ports that you're operating on, and whether or not you're enabling the authentication failure trap. That's if somebody login fails as an administrator, it's going to send a trap. You then set the community name, whether or not it's allowed to write, whether or not it includes traps, and whether or not your SNMP should include your traffic alarms. Set your version, and you can also do custom MIB filtering. The MIBs are available on the Juniper website in the download area with the ScreenOS itself. So if you want to dig in deep and your management server wants to track particular parameters, you can set up those in the MIB filter. And then on the bottom there we see where you set your host restrictions. If you want to make sure that the SNMP requests are only responded to by particular servers or a particular range, perhaps you have a management server range in the data center, you can set up that range in there and restrict what interface they can come in on and what IP addresses will be allowed to receive the SNMP information. If you're using external Syslog, this can also be configured to send the information. So for the Syslog, these standard parameters are all available. Where can I reach this from on the source interface, whether I'm turning it on or off for enable, and we have to set which level of traffic. We have all those things from information debug all the way up to emergency, so you can send some, none, or all of those to be logged to the Syslog server. And of course you need to know the Syslog server IP address and what facility that's coming from. You can set up multiple facilities in ScreenOS. On the web, this configuration is in the report settings. So there are the Syslog servers and which security facility and the event log parameters that we've just mentioned above. You just fill out the form, source interface, etc., and IP address, and away it goes. All your logging will then start being collected by your Syslog server. License keys. There are some features on ScreenOS that require ongoing license fees or maintenance. These are the extended version of the ScreenOS. When you look at the data sheet on the Juniper website, you're going to have base models and extended models of certain ScreenOS devices, and the extended model will increase parameters that you're allowed to use on the device. So for example, on SSG5, small office home, small mid-size office firewall, by default there's a 25 SA limit on VPNs. When you buy the extended license, you get 50 or 40 rather VPN connections. There's a 8,000 session limit of session table on that device. When you buy the extended license, it goes to 16,000. So if you get the extended or advanced release license, that would need to be installed in order to extend those software features. Antivirus, self-explanatory. If you want to be able to filter based on the antivirus engine, you need a license for that, and of course that's primarily because you need to keep the signatures up to date. External URL filtering requires a license. If you're using an internal whitelist or blacklist, no license is required. If you're using WebSense redirect to a separate WebSense server, you're paying WebSense, so no license is required there. URL filtering license is required if you're using the surf control filtering in a cloud. And again, what you're paying there is the keeping the filtering up to date and the category lists active and the like. Finally, there's a deep inspection license available on some models. This is able to make policy decisions and deny traffic based on the content datagram of the traffic, and not simply the ports and IP addresses, but actually what contents inside the device. To install the device, keys. To install keys on the device, first you have to have the device registered on the Juniper website so that the device is registered in their system. You will also get a registration for the license that you have, and then there's a license key area on the website which will generate the key for you. Once you have the keys generated in the web configuration, you can go to update ScreenOS/keys and enter the key there to activate the features, or you can use the license update option on the command line interface, which is an exec command, exec license key update. File management. There is a flash drive, of course, as we discussed in the last lesson, and of course that's where your logging is being maintained. It's also where your ScreenOS image and your configuration file are maintained. You may need to get your ScreenOS image file or your configuration file on and off to the device if you want to do updates, and there are several methods available to do that. These file locations are available depending on the device. Some have them, some don't. There is a USB port on most ScreenOS devices, so you can plug a USB key in there and extend logging and other storage on that device. And you can also then write to that device if you want to write files to there to bring them over to your PC. Using the web interface, you can connect to the ScreenOS device and download either the configuration or the ScreenOS image itself to archive it off the device. TFTP is supported, so if you run a TFTP server in your data center, you can transfer files to that, as we demonstrated earlier, in redirecting outputs of the view log commands. The compact flash is the internal slot that's available on for an expansion on some devices and PC cards. So some of these are not available on all platforms, especially the last two, the compact flash and the PC card. But these are the various locations where you can redirect and either retrieve from or send files to. So saving your configurations. We mentioned in some previous lessons that on the CLI, every time you change things, you're actually changing the running config. When you're done making all your changes, you do have to save at the end of the session. It will only save to the saved configuration when you request it explicitly. In the web, though, when you do modify a setting on the web, it will apply the setting to the running config and immediately issue this save command. From the web, you can also go to this configuration update config file area and either upload or download a configuration file on the web interface. Okay, the manipulation of configuration files is only available to the root system administrator. The other types of administrators we've discussed in the previous lessons are not able to perform these functions. You can, from the CLI command, you can back up the configuration by sending it, in this case here, from the internal flash to a TFTP server. You can restore to the flash drive a configuration that will be active on reboot. So this is the reverse. You're going to save that configuration from the TFTP server to the flash drive. And there is also a merge command. Merge is helpful if you have a whole series of commands that you need to execute to do a bunch of changes. You can put them in a config file all by themselves as you would have typed them on the command line. So you can assemble by copy and paste or generating them from a script, a whole series of commands into a file. And then when you issue the merge command, it's the same as executing them one at a time on the command line. It'll put those right into the configuration for you. After they're in the RAM configuration, of course, you have to then save them to the saved configuration if you want them available in the next reboot. In the web interface, this is what the looks like, and here's those two configuration options again. The merge option is what we just discussed. It's going to merge that set of commands right into the running configuration, and in the web case, it will also save it. The replace configuration is going to copy, as we did in the restore from flash, to the flash drive, but it's also then going to initiate a reboot so that copied configuration then becomes the running configuration. So when you say replace current configuration, you are going to reboot the device. There is an operation for configuration rollbacks. You can create this fallback position if your running or your saved configuration becomes corrupted. You can also have the device default to this if the configuration fails. So it's kind of a last known good configuration that you can save here, or if you're familiar with Junos, this might be the rescue configuration that you have on the device. You also can manually force a rollback to this. So if you have this golden configuration that it's running now and it's good, you're about to make a whole series of pile of major changes to the device, and something goes wrong, you can use this command to manually force back to your starting point. So here are the rollback commands. Save configuration to last known good. We'll take the current configuration that's running on the device and make it the last known good configuration, just like the Junos rescue config. And then the exec command here to use that, allow the use of that rollback configuration. So when you reset the device here, that's issuing essentially the reboot command. If the new configuration is working and you don't want to have that rollback active anymore, the exec config rollback disable would be the prevented from using that configuration anymore. So this is just a safety net, a way to roll back when you're in the midst of making a whole lot of bulk changes. Okay, so in addition to the configuration file, we have the ScreenOS software image stored on our device. We can make a backup copy of that image from the flash to a TFTP server, and we can do upgrades of that image from a TFTP server. So we would save the software from the TFTP to the flash, and then after that's finished copying, we would type the reset command in order to reboot the device and use the new ScreenOS configuration. On the web interface, these same functions are available under Configuration, Update, ScreenOS, and Keys, and you just select the firmware as the option, browse on your local computer to where the new ScreenOS image is, and then hit apply. When you do this in the web interface, it will automatically do the reboot function. So if you don't want to reboot your device, don't click apply in the web. The command line, you can copy it now and come back in 3 hours later and do the reset to apply it. But in the web, it's all in one operation. As soon as you hit apply, it's going to copy and then reboot. Of course, disconnecting everybody currently connected. Okay, so moving on from our management overview to the recovery options. Every once in a while, you may have a problem where your device doesn't boot, or you're experiencing other apparent failures and you want to see what's going on. So in a disaster recovery scenario, you may have a corrupted ScreenOS image on the flash so that the operating system itself is not able to run. You may have lost the root password so that you only have operational administrator passwords to the device and you can't access those root level functions. Or you may have a device you're about to redeploy, so you just want to set it to factory defaults to make sure all the configuration's out of there before you start configuring it for its new location. Okay, so we're going to talk about the recovery boot mode first. This is the scenario where you do not have access, the device is not booting. So in a recovery boot mode from a TFTP server that has a valid ScreenOS image on it, you can connect to this if the interface of your device is in the same subnet as that TFTP server. Which interface you want to have connected to that subnet does vary by model, so you have to check your spec sheet on which interface that request to the TFTP server is going to come from and make sure the correct one's plugged in. During the boot process for the device, you'll see this command appear during the boot process. It'll say hit any key to run the loader. When that appears, you hit, say, the space bar or any key, and you will get the prompt then to be able to run the flash image or connect to a TFTP server to get a new image. If you have lost the root password and you need to reset the device, there's the soft reset option. If you connect a cable to the console cable, as we mentioned in a previous lesson, and use the serial number for both the username and the password, this will initiate the factory default process. This function can be disabled in a configuration using unset admin device reset. So if it has been disabled, there is no backdoor. It won't be able to be used. You can do a hard reset, which is holding the pinhole on the back of the device in until the flashing light goes to the orange color. You then release it for about 3 seconds, and you will see the device change color again, and then you press it a second time to force the setting of refault. If you have a computer connected to the console port while this is going on, you'll actually see those prompts appear, not just the color flashes of light. The timing on this is tricky, so you have to pay attention, and it can take some practice, and it can be frustrating actually. Hitting this right without seeing the prompts is at times tricky. This also can be disabled in a configuration using unset admin hardware reset. So again, there is no backdoor to that. If you have to have the root login to be able to set that again to allow the hardware reset. So if you choose to unset both of these devices, you must have a root login to be able to do any kind of reset. So don't lose the root password if you choose to disable these two options. The procedures for this are posted on the class website, so you can download them and review them in detail there. So in this session, we've worked with device counters and logs and described where you can get this kind of information from ScreenOS, either on the device or using external management devices to store the information long term. We've showed how to connect external management servers like DNS, Syslog, and Network Time Protocol to your ScreenOS device. And we've discussed how to manage your license keys for additional feature sets that you've purchased for your device. And finally, we've discussed how you go about manipulating your configuration and your image files on the device itself. And we've performed or reviewed how to perform the factory resets procedures and also the recover from a TFTP server from a corrupted ScreenOS image. Those procedures are posted on the class website that you can download and review in more detail. So this brings us to the end of the lesson on management and recovery procedures on ScreenOS. I thank you for your time and attention. If you have questions about the material that was covered in this lesson, feel free to either send me a private message via the contact information on the class website or post a public question in the class forum that's available at the top of the class website page. I hope you enjoyed your stay here, and thank you for your time and attention.